ऑफ कर दूं इसको?
हाँ जी, स्टॉप कर दो।
स्टॉप भी नहीं ना हो रहा, ये मैं इसको ऑफ करके ही फिर जाती हूँ। यू आर प्रेजेंटिंग, स्टॉप प्रेजेंटिंग, या देन ओके नाउ present now my entire screen, and can you see my screen?
अभी मैम वो आइकन होगा, उस पर क्लिक करके फिर शेयर करना है आपने।
मैं स्क्रीन नजर आ रही है आपको?
नहीं मैम,
नहीं आ रही ना अभी भी, तभी तो कह रही हूँ शेयर में।
हेलो, गुड आफ्टरनून मैम।
हाँ जी, गुड आफ्टरनून मीनू, कैसे हो? जस्ट लेट मी स्टार्ट दिस थिंग।
प्रेजेंट हो रहा है मैम।
ये तो हो रहा है, बट इससे वो कैसे आएगा? सेलेक्ट नहीं हुआ ना वो।
नेम शेयर,
ये स्क्रीन शेयर तो हो गया, बट वो पीपीटी नहीं सेलेक्ट हो रही। लेट मी अगेन स्टॉप शेयरिंग। ओके, देन
विंडो पे तो क्लिक करना,
प्रेजेंट नाउ है ना? अब विंडो पे आएगा मेरा ख्याल है, विंडो पे करके देखो। या नाउ दिस इज ओके। विंडो पे आना चाहिए था। हाँ, अब नाउ दिस इज शेयर। हाउ अबाउट दिस? अब आ रहा है? या नाउ दिस इज देयर आई थिंक। ओके, इट इज ओके नाउ।
यस मैम।
हाँ जी, अभी अब शेयर हो रहा है। Ramnivas, can you see now?
Yes, ma'am, it's visible.
Up to have visible. Now you can start. फिर वही हो गया। एक मिनट what happened? You will do this start, this share. Yeah. Now, is it okay?
Yes, ma'am.
ये full screen आ रहा है आपको? Can you
Yes,
see the full screen?
Yes, ma'am.
Okay. Okay, then it's
Yes,
okay.
ma'am.
Now you can start.
Okay ma'am, thank you. May I now request the principal of our college, Dr. Balraj Thapar, to kindly introduce our eminent speaker, Professor Kalpana Maharaj. Principal.
Good afternoon, ladies and gentlemen. Esteemed Professor Dr. Kalpana K. Mahajan, honorable members of the staff and dear students. It's a matter of great pleasure and pride that a person of Professor Dr. Kalpana K. Mahajan's stature and eminence is amidst us as a resource person. Her words of wisdom will be a source of inspiration and stimulation for all of us. We are deeply beholden to her for sparing her valuable time to be with us on this occasion. Dr. Kalpana K. Mahajan is the professor and coordinator of UGC DSA 3, and he is former chairperson Department of Statistics, Punjab University, Chandigarh, and she has been a member of the faculty of Department of Statistics, Punjab University since 1977, and she has been professor in the department since 2001. Her research interests are in inference, multiple comparison procedures, income inequalities, environmental statistics. Besides that, she has co-authored 4 books and 2 projects reports, about 50 papers in the leading international and national journals. She has been on the editorial board of International Journal of Statistics and Reliability Engineering, International Journal of Statistics Application, published by SCI Tech Publishing, Punjab University Research Journal, She is a guest editor of Journal of Statistics and Applications, Special Proceeding Volume IMS SCT 2012. So far as the seminar and workshops are concerned, she has participated in many workshops, conferences, and seminars as a keynote speaker, invited speaker, and section chair, delivered more than 150 lectures and presentations since 2011 on the program committee of Global Science and Technology Forum, which organizes international conference, ORS, Operation Research and Statistics. She has organized more than 20 seminars, workshops, including as the chair of International Conference FIM 2012. In addition to that, she has held the various positions and she has been coordinator since 2008 of UGC SAP DSA Department of Statistics. She has been chairperson, head of the Department of Statistics for 2 terms, that is from April 1991 to March 1994. Then from April 2019 to March 2012, she has been chairperson, Committee Against Sexual Harassment of Punjab University from the August 2010 to August 2013. She has been Dean Student Welfare Punjab University from August 2010 to 2013. She has been warden from July 1993 to June 1993. She has been on the selection committees, on expert advisory committees of UGC, DST, and NAAC, on the panel of number of selection committees of various universities and commissions such as PPSC, SSC, JK, SSC. Webinar on which she'll be speaking, that is statistics and its application, is very interesting and very relevant. In the ancient times, statistics was regarded only as a science of statecraft and was used to collect information related to crimes, military, wealth, etc., for devising military and fiscal policies. But with the concept of welfare state taking roots almost all over the world, the scope of statistics has widened to social and economic phenomena. Moreover, the development in the statistical technique during the last few decades, statistics is viewed not only as a mere device for collecting numerical data, but as a means of sound techniques for their handling, analyzing, and drawing the inferences from them. Accordingly, it embraces all sciences, social, physical, natural, and is finding numerous applications in various diversified fields such as agriculture, industry, sociology, planning, economics, business, management, psychometric, insurance, accountancy, and so on. It is rather impossible to think of any sphere of human activity where statistics does not creep in. It will not be exaggeration to say that statistics has assumed unprecedented dimensions these days, and elementary knowledge of statistical methods has become a part of the general education in the curricula of many universities all over the world. In fact, to a very striking degree, the modern culture has become a statistical culture. There are numerous other areas where the use of statistic is so common that without its use, they may have to close down their operations. Now, I'll not stand between you and Dr. Kalpana K. Mahajan. Thank you very much for being with us. Thanks a lot.
Thank you, sir. Thank you very much. Can you hear me?
Sure,
Okay.
madam.
Thank you so much, Dr. Balraj Thapar, principal of the college, for very high words for me. Thank you so much. And he has explained the importance of statistics in a very unique way. And we know that, we all of us know that without statistics, no discipline is, every discipline needs statistics. Okay? So before I start my lecture, I first thank Professor Dr. Balraj Thapar, and also the teacher, or what I say, I think he's the only teacher in this statistics department, Dr. Ram Nivas, for giving me an opportunity to interact with you people. And let me tell you, your Department of Statistics is a very good department, because every year we get very good students from your department. They perform really well. Okay? So mm, I will just now come to my topic. I think you can view full screen, or this is just, if it is not there, then I'll have to start it again. But is it okay, Ramnivas?
Yes, ma'am.
The screen is okay?
Yes, ma'am. You can
Okay.
start, ma'am.
Okay, so now let us come to the statistics and its applications. As Dr. Thapar told you that in all the disciplines we use statistics, but when it comes to the statistics, when we talk about the statistics, so many types of things come to our mind, and we can see so many sayings which are there for the statistics. The very important, the very popular is there are three types of lies: lies, damn lies, and statistics. Another is statistics is the grammar of science. Carl Pearson, you know the person, he has a great contribution in the statistics. Okay, and normally we see these types of quotes. They are given by the foreign authors. You just look at any, you can see the names of the foreign author.
Ma'am,
So, Hanji,
click on play button.
which thing?
Please click on play button
Play button. Where is that?
above the PPT, right corner.
एक्चुअली इसमें ना थोड़ा लेट मी डू इट अगेन प्ले आई थिंक इट्स नॉट प्लेइंग
Ma'am, for full screen.
फुल स्क्रीन में प्ले में ना इसमें नहीं आ रहा आई हैव जस्ट सेलेक्टेड द स्लाइड शो इसमें ना वही मैं आपसे पूछ रही थी ना पहले
Okay,
मैं इसको देखिए ये अभी फुल स्क्रीन हुआ नहीं हुआ आई
okay,
डोंट थिंक
you can start.
नहीं हुआ नहीं ना फुल स्क्रीन नहीं हुआ
नहीं हुआ.
मैं अभी इसका ना फिर एक मिनट जस्ट वेट
Yes,
होल्ड डाउन मैं इसका ना एक और वर्जन है उससे ट्राई कर सकते हो जस्ट
Yes.
5-3 मिनट्स में है ना स्टॉप शेयरिंग लेट मी look at this make one more icon where is that yeah I think this will work that's why I was telling you कि हम इसको पहले थोड़ा शुरू कर लेते हैं yeah? ये नहीं हो पाएगा this I should go to present now my entire screen then I will select
Samim sir. Issue.
अभी भी नहीं हुआ ना
No, ma'am.
ओपन भी किया मैंने इसको ओपन करके रखा है उससे फिर पावर प्रेजेंटेशन नहीं बन रही ना जैसे मैं इस पे जाती हूँ जस्ट आई शुड सेलेक्ट दैट ना स्क्रीन से जाके ही सिलेक्ट होगा शेयर
Ma'am,
में
आप सेपरेट विंडो में ओपन कर लीजिए इसको.
हाँ
पीपीटी को सेपरेट विंडो में ओपन कर लो.
मैंने वही किया था ना यू आर प्रेजेंटिंग योर स्क्रीन
मैम शेयर एंटायर स्क्रीन करके तब कीजिए
मैंने वही किया है बट नहीं हो पा रहा ना एक मिनट जरा रुको लेट मी स्टॉप शेयरिंग प्रेजेंट नाउ ओके देन अ विंडो में ही सेलेक्ट नहीं हुआ अभी ना एक्चुअली विंडो में स्क्रीन कैसे आएगी ना ये आ नहीं रही मेरे पास ना पहला ही ठीक था फिर दिस इज माइक्रोसॉफ्ट वर्ड जो विंडो आया उसमें से कैसे सेलेक्ट होगा शेयर में हाउ आई एक्चुअली मैंने गूगल बहुत कम यूज किया है, so this is the problem. Just wait, hold down, मैं हेल्प लेती हूँ किसी की. Okay.
मैम, कल्पना मैम, ऐसे कैसे होगा इस
हाँ जी, प्रेजेंट हो रही है अभी.
Good afternoon, students. There is some technical issue and we'll just wait for another 5 minutes and let ma'am join again so that she can present the PPT. Thank you.
टेक्निकल फॉल्ट की वजह से मैम थोड़ा टाइम लेंगी, 5 मिनट्स वेट करो सभी।
Okay, sir.
हाँ जी, कैन यू हियर मी? हेलो
Yes, yes ma'am.
रामनिवास,
Yes ma'am, you are audible.
मेरे को लगता है इसमें कर
She left. Away.
हेलो, आर यू देयर? मैं प्लीज, आई एम वेरी सॉरी, अभी थोड़ा सा मैं ना लिंक नहीं मिल रहा दूसरे कंप्यूटर पे, जस्ट वेट। उसके दूसरे
Okay.
वाले ना खुल नहीं रही, इसके ऊपर पीपीटी नहीं खुल रही, जो बनाई थी ना पीपीएसएक्स वाली।
यहाँ पे है नहीं यार,
हाँ?
रामनिवास का रिवाइजिंग कहाँ पे है? इसमें
हाँ?
है ही नहीं।
क्या
कहाँ है इसमें मेल? कोई
मेरा मेल खुलना, डॉक्टर इमास ऊपर करना,
हो रहा ही नहीं।
इसमें तो है, मैं क्या करूँ? इसको खोलो जरा।
ये थोड़ा है।
चलो मेरे को ऐसे ही कर लेना,
ऐसे ही करो, चलो ऐसे ही करो।
अब ये फोन कर दीजिए इसको। अब इसमें नहीं हो रही प्रेजेंट, मेल भेजूं आपको फटाफट? हाँ मिल गए?
नहीं, कौन से भेजोगे? कहाँ भेजोगे मेल?
रामनिवास अपडेटेड इंफॉर्मेशन, फॉरवर्ड, इंक्लूड अटैचमेंट। पर आपके फिर आर के महाजन से होगा ना, के महाजन से कर दूं?
हाँ कर तो भेज दो, मैंने आपको खोल
भेज दिया आपको ना, अभी भेजिए।
मेरे को भेजी थी, मेरे को
मेरी क्योंकि वो लिंक मेरा ही आएगा ना। हेलो,
Yes ma'am.
हाँ प्लीज, मैं ना अभी दूसरे लैपटॉप से ट्राई कर रही हूँ। आई थिंक देयर इज सम प्रॉब्लम विद दिस लैपटॉप।
आप मुझे सेंड कर दो मैम।
और क्योंकि मुझे वापस में ना वो नहीं मिल पा रहा था।
ओके मैम।
हो गया?
Hello, yes ma'am. This is visible ma'am. Kalpana ma'am. Ma'am, your PPT is visible now. You can start. Am I audible, ma'am? Hello, Kalpana ma'am.
अब इसको छोड़ो, सीधा से करो अपना काम।
इसको ना इसको
नहीं,
मिनिमाइज करना।
छोड़ो यार।
Ma'am, you are audible now. You can present now.
Okay. Sure.
PPT is visible now.
Okay, thank you. So let me start again. I'm extremely sorry for this distraction, this disturbance, because somehow this was not working on this laptop. So let me start it again. We can take some more time because he has already fixed up to 4:30. So, and let me tell you, if there is any question, either you put in the chat box or we can discuss afterwards. Okay? So now let us start from statistics and its applications. As I already started, I told you that there are so many sayings about the statistics. The very famous one is there are three types of lies: lies, damn lies, and statistics. And then statistics is the grammar of science by Carl Pearson. Everyone knows about the name Carl Pearson. And all these things, they are by the foreign authors. And just recently, we have also made some compilation of the sayings of Indian authors. And you can just go to the YouTube channel and search for statistics. So say Indian scholars, you will find so many sayings about statistics by the Indian scholars. Okay? Another one is a single death is a tragedy, a million deaths is a statistics. Then 99% of all statistics only tell 49% of the story. But whether you appreciate statistics or you criticize it, you cannot survive without statistics. Why? Because data is all pervasive. Everywhere you can find out the data. You talk about any discipline, sports, politics, economics, physics, chemistry, any discipline, data is everywhere. Now let us come to the data. If you go for any data, if you go for any collection of data, you can collect the data on so many variables, so many attributes. Okay? And the simplest thing is look at these things, and we have collected a small data, and it will look like this: gender, residence, whether rural and urban, marital status, family size, age, weight, and weight of father. And you can go on increasing different variables, and after the collection of the data, it will look like this. Okay? Now, what are the types of data? If you talk about the data, we can talk about these terms: qualitative, quantitative, attributes, variables, discrete and continuous, categorical and measurable. And another very important term which is very popular these days, that is structured data and unstructured data. All these are the forms of the data. Okay? Structured data means when the data is given in the compiled form, a proper form. Unstructured data is when this is a raw data, and you are not you have to compile it and get the information, extract the information out of that data. And when you go for the collection of the data, either the data will be qualitative or quantitative. Data will be on attributes or on variables. It may be discrete or continuous, categorical, measurable. These are all forms of the data. Those who know about the statistics, they know these terms. Okay, because data can be measurable, data can be in figures, or it can be just qualitative data. Some norms will be there. And if you go for the collection of the data, there are 4 types of scale on which you can collect the data. The first one is nominal scale. Nominal scale means you collect the data on the basis of norms, like male and female, like success and failure, bus, car, by names. You can specify them by name. So this is called nominal data. And ordinal data is where the ordering of the this concept is there, means high, very high, low, average, like this. So we order the data, and this is called the data on the ordinal scale, means low, high, etc. And then comes to the interval scale. Interval scale is when you have some figures. Your data, your observation lies in some interval, okay? Numeric value. But in the interval scale, we use the concept of arbitrary zero. Means when we say that a person uh, gets score 0, what does it mean? It doesn't mean he is 0, is nothing. His IQ level is 0. No. So here we use the concept of arbitrary zero. To get rid of this, we go for ratio scale. Here 0 means 0, 0 means nothing, like you go for that Kelvin scale and temperature. So it means the meaning of 0 is there. So normally when you go for the collection of the data, we use nominal scale, ordinal scale, and interval and ratio scales, they are merged. Here you will have some figures, some numerical data will be there. Okay, so you collect the data in this way. And then again, one small this film is there on YouTube, the term data. It will tell you what type of data is there. All the terms will be explained in that. So you can go through this, just search on YouTube and you can find out this. But now come to the basic thing. Now come up to this statistics. What is the basic purpose of statistics? You know, all of you study statistics. You have read so many papers. After taking the admission in statistics, there are so many papers which you see. But what is the basic purpose of statistics? The basic purpose of the statistics is, we can just define this purpose in two ways. The first thing is to find or to get how we can express the data in minimum possible terms or words. How you can express the data in minimum possible terms. And the second thing is, what is the typical message hidden in the data? So the first type of thing we say to describe. And the second one is known as infer. So to describe and infer. Okay. Now again come to the data. What you can do with this data? You can describe the data. You can you can get the inference from this data. Describe and infer about individuals, about institutes, about processes, about phenomena. So when it comes to the description, so now we'll be talking about the two things, the two basic things in statistics: to describe the data and to make the inference. So when it comes to the description part, this is very easy. You can just count the number of males from your data set. How many males are there? How many females are there? How many of them are married? What is the average age of the persons? This is the description of the data. And in inference, what type of problems will be there? Can we say that more male than female attend classes? Can we get the answer of this question? Or can we say that the weight of the father is more than that of the son? So again, come to the description part, how to describe the data. You can take any variable. It may be attribute, it may be variable, and you can describe the data. Data can be on univariate, on bivariate, or on multivariate variables. So description can be there. So when it comes to the description part, what is the basic thing? From the data, a data is very large, very big data is there. So first of all, what do you do? We go for the tabulation, just to compile the data from unstructured data to structured data. Okay, so we go for the tabulation, we make a table, then again we go for the diagrams. Just from the basis, on the basis of the tables, we make some diagrams, we make some graphic presentations, and then from this data we can go for different measures. The basics are measures of central tendency, MCT, measures of central tendency like mean, median, mode, etc. Then measures of deviation, because with the location, with the central tendency, we want to know the variation in the data. So we go for measures of dispersion. And if you have a bivariate data or multivariate data, you can go for correlation, you can go for regression, so on. Now tabulation, when it comes to the tabulation, the tables may be simple, it may be complex. Okay. Measures of central tendency, you can talk about one variable, separate variable, you can find out the measures of central tendency, and so on. This is how you describe the data, you know. And then if your data is categorical, if your data is qualitative, like males and females, you have just recorded the in terms of how many males are there, how many females are there, the data is like that, and you just compile the data in a tabular form. So see how this looks like. Male, female, and total number of persons in the group. There are 30 persons, out of them 13 are males and 17 are females. Okay, so this is the gender-wise distribution of the class in terms of that categories. Categories are male and female. Then again, if the data is on the interval and ratio scale, then what you do? You make the frequency distribution table. You make the frequency distribution table on the basis of their weights on the basis of their heights, on the basis of their incomes. Okay, so grouped frequency distribution tables, different distributions and tabular and graphic representations, you can describe the data. After making the frequency distribution tables, you can go for different diagrams. So look at these common diagrams which are used in statistics on the basis of frequency distribution. Simple bar diagram is there, multiple bar diagram is there. Then this is divided bar diagram is there, circular diagram is there, pie diagram is there, and so many diagrams. And this is histogram. This is ogives. Now, what is the difference between the diagram and graph? These are the diagrams, and ogives and histogram, then frequency curve, they are the graphs. What is the basic difference? In diagrams, we use only one axis. Either you can use x-axis or you can use y-axis. But in graphs, we use both the axes. In histogram, one x variable is there on the x-axis and the frequency is there on the y-axis. Similarly for the frequency curve, etc. Okay, so these are the ogives and these are the histograms. They are the graphs, but all these, they are the diagrams. Clear? So this is how we can represent the data, a very big data. First, we compile the data into a frequency distribution table, and then we can go for different diagrammatic representation of the data by using different diagrams. And then after you can find out the histogram, you can draw the histogram, you can frequency curves and ogives, etc. by using the same frequency distribution table. Okay? So all these things, they are the part of description. After that, after describing the data in terms of diagrams, we can go for different measures. What are these measures? Measures of central tendency, the very common thing. First of all, we'll go for different averages, arithmetic mean, median, mode, etc. to get at a representative value. But to supplement these measures of central tendency, because only the average will not serve the purpose, they will not give you the clear-cut picture of the data, we go for measures of dispersion, the variability in the data, like mean deviation, standard deviation, quartile deviation, range, etc. Yeah? So these are obtained from the data. So similar techniques are available for bivariate and multivariate data. Correlation and regression, they are used for bivariate and multivariate data. So in correlation, if you go for correlation, how to find out the correlation between the two variables? Bivariate, in case of bivariate distribution, go for the correlation. The simplest way is to draw a scatter diagram. You can see what type of correlation is there, positive, negative, or whatever. You can draw the scatter diagram. Then the most important thing is called Pearson correlation coefficient. That will give you the measure of the strength of the relationship between the two variables. Then Spearman's rank correlation coefficient. This is based on the ranks of the observations. If instead of the original observations, we have ranks of the observations, we go for Spearman's rank correlation coefficient. So this is the scatter plot, scatter diagram. This will show you that if one variable is increasing, other is also increasing. So some sort of positive relationship is there. If other way, if one is increasing, other one is decreasing, we can judge that negative relationship is there. Okay, and this is the regression line. Again, all the techniques are there to get at the regression line, to correlation coefficient, regression coefficients. But all these, they come under the description part. The first part, the first rule of the statistics. Out of the data, you can get all these measures, describe the data. Finally, you can give your statements like this: the class is having this much number of students, out of them so many are male, so many are female, and this is the average age of the persons, this is the average weight of the persons, and correlation, etc. Okay? But after the description, after getting these so many measures, what do we get? There are so many questions. For example, The statement is more female than male undertake statistics or mathematics courses. Or average weight of the persons attending classes is 65 kg. Or is there any relationship between age of father and his son and daughter? Can we get the answers of these questions out of the descriptive part of the data, out of the descriptive part of the statistics? So this comes, the first one is description. You can just write down these number of the persons in the class, number of married, number of average age, etc. But in inference, what type of decision, what type of inference you can make? Now look at the two statements and see the difference. One may say more female than male attended the courses. And the second one is more female than male attend the courses. What is the difference? The two statements are there. You can just see the difference. The first one is describing the complexion of the particular batch. And the second is making a time and space free statement, a general statement. Clear? In the first one, you are just taking the decision, you are just observing that in a particular batch, you just count the number of males and count of the number of females. You can just take the decision that more males are there who have attended the course. But in the second case, we are making a general statement. More female than male attend the courses. Yeah. So this is the time and space free statement, a general statement. Now, let us see how to get these types of decisions, how to make such types of decisions, such type of inferences. Again, come to the same data. Same data, you can go for different measures. For descriptive part, you can compute different measures of the, there are so many variables. You can add on other variables also in the data. Okay. So you can get the descriptive measures, but how to use the inference part, how to take the decision. Now, this is the data. Let us focus on one variable only. What is that variable? Let us say weight of the participants. You can pick any variable. I hope some social sciences faculty members or students are also there. They just deal with data and go for such types of statements, such type of inferences. Okay, so they can pick any variable and let us see how we can exploit this variable in order to get certain inferences. So let us say our focus in this data is on the weight of the participants. So weight of the participants, just pick one variable. Can we say the weight of the participants is 65 kg? Average weight of the participants is 65 kg. Clear? Now, the second case, just one variable, weight is the variable, but you can divide the whole data into two parts, male and female. Clear? The same variable is there, but you have divided this into male and female. So two sets of observations, two different samples. So you have divided one sample into two different samples. Now, what will be the problem? What will be the question? Can we say the average weight of female participants is same as average weight of male participants? And the third one is, suppose the same group of persons are there. Your focus is on the weight of the participants. Same group of persons are there. Some treatment is given and then again their weight is recorded before and after treatment. So this type of thing is called paired comparison. These two samples, they are dependent samples. Like here you can get they are dependent samples because the observations are made on the same group of persons, okay, before and after. So there was only one variable, weight, and we have made three cases. Single sample, then two independent samples, and then two dependent samples. Here. So again, now, again, let us see how to use these inference things, very small examples. So you will get to know the importance of this statistical inference, decision making, how we make the decision. Everybody uses statistics, whether we know statistics, whether we don't know statistics, but we are using it. How? You go to the market, you purchase certain thing, You decide whether you should buy it or not. How do you decide? You take a sample of few observations. You just observe. If you find the product is good, you go for the purchase of that. Otherwise, you reject that. Your decision is based on that small sample. So this is a small example. Suppose a person wants to purchase this certain cold drinks, soft drinks for some occasion, and he went to the market. He just look at the 10 bottles of the soft drink of particular brand and found that average weight of these 10 bottles came out to be 295 ml with standard deviation of 5 ml. What he did? He filed a case against company on cheating. Why? Because company said that the average content in these soft drink bottles should be 300 ml with the standard deviation of 10 ml. The company said that their product is as per the specifications. The specifications are the average should be 300 ml with the variation of 10 ml. Clear? But he rejected the lot just on the basis of his sample. Then again, let us say another person, and he took another sample. The first sample gave him 295 ml, and when he took the second sample, the average content of that came out to be 305 ml with standard deviation of 5 ml. Then what to do? So in both the cases, company justifies that product is as per the specifications. The average should be 300 ml, but some variation is also there. That is 10 ml. This is a pre-specified. Okay. So now, what is the cause of this? Why this variation? There are two samples. In the first sample, the average content came out to be 295 ml. In the second sample, it came out to be 305 ml. Why? The variation could be due to cause and effect. Sometimes the cause is known, why this variation is there, or by chance. And chance is due to sampling. Clear? And in both the cases, the company is right saying that their product is as per the specifications. But how a person took the decision? He took the decision on the basis of small sample, 10 bottles in both the cases. Clear? Now again, come to the, what is the message in this example? It means based on the sample observations, we take decision for the population, for the total. So how to take that decision? Statistical analysis is carried out to draw inference about population on the basis of samples collected from the population. Clear? Now, and come to the another example. How to take the decision? How we can check these types of statements? There is a genetic law. All of you must be knowing that. It says that the children having one parent of blood group M and the other parent of blood group N will always be one of the three blood groups M, Mn and N. And that the average number of children in these groups will be in the ratio of 1:2:1. So this is a law, genetic law. Can we test it statistically? Yes. We can test this law statistically and look at this, the results. An experiment states, an experiment was conducted on the 162 children. All these children, they were having one parent as M, another was N, and the result was 28.4% were found to be of group M, 42% of group Mn, and rest of group N. Do the data conform to the expected genetic ratio 1:2:1 on the basis of it? We can apply certain statistical tools and confirm this ratio. Yeah? So now the problem comes out to be how to test. You know the testing thing? From these different examples, you should be able to know the importance of taking the decision. But how to take the decision? What are the statistical techniques which will be helpful in taking the decision? So normally, if you ask anyone, he will say the TF ANOVA. These are the common tests very familiar tests which are used for taking the decision. Very common test. T test is there. The test statistics is known as the T statistics. This is normally used for the population means, single mean, two means, more two independent samples, two dependent samples. Okay. Then another is if we have more than two samples, then another very popular technique, analysis of variance, ANOVA is used. And if the sample size are large, we go for Z test. Similarly, for testing the variability in the data, we go for chi-square test, we go for F test. These are the common tests. But the problem is how to select the test. You know the tests, you know the names, you are familiar with them, but how to select the right statistical test? Because I know, I understand amongst you, some statistics students are there, some other students are there. And normally the other persons who go for the analysis of their data, they come to the statistics persons. So statistics people, they must know how to select the right things for their data. So how to select the right statistical tests? So first of all, you will look at the data. How will you decide which test should be applicable? What is the nature of the data? Data कैसा है? Data numerical है, non-numerical है. What is their aim? What is their objective? And secondly, you will look at the sample characteristics. You have sample observations, you have data. What type of characteristics you can have from the data? We'll explain this later. And then what type of inferences they want? What type of decision they want? So inferences to be made. So let us come to the basic terms which are used in decision making, in inference. Very common terms, very basic terms. The first one is statistics and parameters, then statistical hypothesis, errors, and test statistics. These are the things which are used for statistical inference. Okay. So first of all, what is the word statistics? How do we define statistics? If you talk this statistics in plural sense, it means data. In singular sense, this is a subject. Similarly, you call different formulae also as a statistics. And in this inference thing, we call statistics as the characteristics of the sample. You know, there are two things. One is population. You want to take some decision about the population, but you cannot collect the data on the whole population. You will go for samples. So there are two things, population and sample, and on the basis of sample, you take the decision about the population. So statistics are characteristics of the sample. So this is another small this YouTube video, the word statistics. Okay, all the definitions of statistics you can find on this. Okay? So the characteristics of the sample will be known as statistics, and characteristics of the population, they will be known as parameters. Population is very large. So how to get the representative of the population, the characteristics of the population? They are fixed. They are known as parameters. But on the basis of samples, we get the characteristics of the sample, we estimate the population parameters. You can have so many samples from the population and you try to be close to the population parameters. So the characteristics of the population population are known as parameters, and characteristics of the sample, they are known as statistics. And just to distinguish them, we represent the parameters by the Greek letters. What are these letters? Mu, sigma square. Normally mean is represented by mu, variance is by sigma square, and the characteristics of the sample, they are x bar, s square, like this. So English letters, they are used for the sample characteristics, and Greek letters are used for the population characteristics. Okay, so this is x bar and sigma, etc. Now the second term is statistical hypothesis. You should be clear about these terms before going for this inference techniques, how to take the decision. We should be clear about these terms. The second one is statistical hypothesis. So most of the statistical hypotheses, they are concerned about the parameters of the distribution. So we make certain assumptions about the characteristics of the population, or what we can do. We can make statement about the future event, or about the outcome of an event which is unknown, and we are open to reject the same. So your hypothesis will be a statement, an assumption, or a guess, which may be true or may not be true. And these statements or these guesses, they can actually be tested statistically. They are called hypotheses. Clear? So this is a statement about the parameter, one parameter, two parameters regarding the distribution, probability distribution, etc. And now this is a small example. See how we can state the hypothesis in this example. We may say that the average age of employees in a factory is normally distributed with mean 32 and standard deviation 10 years. So what type of hypothesis we can make? As I told you, the hypothesis can be a statement about the probability distribution. It can be a statement about the parameter of the distribution. Okay, so in this statement, what type of hypothesis you can make? The first one can be the distribution of the population is normal. See, आपने statement दे दी normally distributed. Can we check that from the data, from the sample? Yes. So this will be a hypothesis statement. This is regarding the statement about the probability distribution. The distribution of the population is normal, or the distribution of the sample is normal. What another hypothesis can be framed out of this? The average age, the mean age of the employees is 32 years. So mu is equal to 32. This will be another hypothesis. And another one is standard deviation is 10, or that variance you can say 10 years. Standard deviation 10 is too large. 100 years gap nahi ho sakta. This is variance. The variability in the data is 10 years. So the hypothesis will be sigma square is equal to 10. So from this small statement, we can frame three hypotheses. Yeah. So then naturally, when you go for the hypothesis, suppose that is not true. It means there should be another hypothesis also. So normally we define two hypotheses, null hypothesis and alternative hypothesis. If we reject the null hypothesis, we go for the alternative hypothesis. So we always talk about the two hypotheses, or a pair of hypotheses, null and alternative. And normally the null hypothesis is stated in an exact manner. Null hypothesis is normally denoted by H naught. Null hypothesis is denoted by H naught, and this is the exact one. Means there is no difference between the procedures. And let me explain this with the help of an example, because if you want to say that in the two populations, same example, male and female, the average weight of male is more than the average weight of female. Suppose you want to check this thing, but your null hypothesis should be the average weight of male participants is equal to the average weight of the female participants. So null hypothesis should always be a hypothesis of no difference. There is a theoretical reason for this, because ultimately when you define a test statistics for testing the null hypothesis, you want to know the distribution of the test statistics. So for this exact hypothesis, it will be easy to find out the distribution. Alternative hypothesis is very vast. When you specify the value, the exactness is there, you will be clear about the test statistics. Okay, so normally the null hypothesis is stated in an exact manner, a hypothesis of no difference and denoted by H naught. And then alternative, you can just put anything in that. It is not equal to that particular value. It can be greater than that value. It can be smaller than that value. Okay, so alternative can be three types of alternatives for one null hypothesis. When we say mean is mean of the just take the previous example, or just take the example of the weight of the participants, where we made the statement, can we say the average weight of the participants is 65 kg? So what should be the null hypothesis? Mu is equal to 65. What are the possibilities of the alternative? Mu is not equal to 65, or mu is greater than 65, or mu is less than 65. So three alternatives can be there. So this depends upon your problem, what type of alternative you should select. So we'll come to the examples, and then we'll see that how to choose the alternative. Clear? So now the third one is errors. What are these errors? What are these statistical errors? Okay. Now these errors are when we apply any testing procedure for any statistical hypothesis, we can make two types of errors. The first thing is just don't look at these examples. Take the same example which we had in the case of that soft drink bottles. In the first case, it was the average weight came out to be 295 ml. And on the basis of that sample, the person rejected the lot. But the product was of very good quality. It was according to the specifications. So what he did? He committed an error. The product was good, but he rejected that. Similarly, in the second case, the average came out to be more than that. Instead of 300, he got 305 in his sample. He tempted to accept that, but product was not of good quality. Just due to his sampling, he attracted to accept that hypothesis. Again, in this case, he committed the error. So the errors are of two types. The first one is null hypothesis is true. The lot is good, but he is rejecting that. We are rejecting that. So rejecting the null hypothesis when it is true is known as type 1 error. Accepting the null hypothesis when it is true is correct. There is no error. Rejecting the null hypothesis when it is true. Just look at the same example. He rejected the lot just due to his sampling. He committed type 1 error. Clear? Now in the second case, the hypothesis is false, but he accepted this, maybe due to his sampling. This is again, he committed an error. This is known as type 2 error. Then it was false and he rejected this. So this is the correct statement. So in testing procedures, in this statistical inference, in taking the decision, there are two types of errors involved. The first one is known as type 1 error, rejecting the null hypothesis when it is true. Second one is type 2 error, accepting the null hypothesis when it is false. So what should we do? We should minimize both the errors. First of all, let us see what are the risks of wrong decisions. What are the probabilities of committing these two errors? The probability of committing type 1 and type 2 errors, they are considered as risk of wrong decisions. So how you can minimize the error? Our decision should be such that the error should be minimized. So how we can minimize that? Just suppose we want to decrease the type 1 error, we want to decrease the risk of type 1 error, definitely the risk of type 2 error will increase, or vice versa. So we have to make the balance. How to make the balance? Either you go for increasing the sample size, you just go on increasing the sample size, your sample will be large. your decision may be more accurate. Okay, so but if in some situations it is not possible to go for large samples, then how to select this, how to make the balance. Okay? Now look at the again look at the two types of errors. Which error is considered to be more dangerous? In the first case, you are rejecting a good lot. It is true, but you are rejecting. In the second case, you are accepting the bad one. So which one is more dangerous? Definitely, the type 2 error is more dangerous because you are taking a wrong thing. You are accepting a wrong hypothesis. You are accepting a wrong product. Okay, so in testing, what we do, we try to minimize type 2 error by fixing type 1 error. By fixing type 1 error at some level. Let us say we take the 5% risk of committing type 1 error. So we take the probability of type 1 error as 0.05. Then on the fixing this, we will minimize type 2 error because type 2 error is more dangerous. So the whole testing theory, the whole decision process revolves around these things and the minimization of the errors. Fixing type 1 error, minimizing type 2 error. Okay. So type 1 error, the probability of type 1 error, the risk of type 1 error is known as alpha. This is also called level of significance, a very common term, level of significance or size of the test, and this is denoted by alpha. Probability of rejecting the null hypothesis when it is true is called alpha. This is a level of significance, very important term in statistical inference. Okay, this is another thing is how to decide about the sample size. Formula of sample size is also there. Sometimes the social scientists, they come to you and ask about that, how we select about the sample size. How to select about the sample size? You just there are so many formula available. आप sampling पढ़ते होंगे and you can see that so many formula are there for the selection of sample size. This is the very common formula and अभी आपको ये इतना समझ नहीं आएगा because you are not familiar with the other terms, but you can get the formula and tell them that we can decide about the sample size. Okay. It depends upon the margin of error, confidence interval, etc. And then your tabulated value, your level of significance, and so many things. Okay. But now again come to the alpha, the level of significance that is more important. Alpha and beta. Probability of type 1 error is alpha. Probability of type 2 error is beta. These are the common terms, common notations, and the rejection region where you reject the null hypothesis, the whole region, you can say just like if the normality is there, you are considering the normal population, the normal curve will appear. And in the rejection region, you have seen that upper and low tail small values, they will be in the rejection region. They are called critical region. And inside the curve, this is the acceptance region. Okay. So critical region क्या होता है? Critical region is where we reject the null hypothesis. And acceptance region is where we accept the null hypothesis. So how to decide about the critical region? That will depend upon alpha. Okay. So alpha is normally taken as 0.05. आपने सुना होगा कभी हम 0.05 लेते हैं, कभी हम 0.01 लेते हैं. जो आपने जिन बच्चों ने पढ़ लिया होगा कि कुछ इन्फरेंस के बारे में, तो आपके ये माइंड में आता होगा कि why we are taking 0.05 and why we are taking 0.01. So when we take alpha, the level of significance, 5% level of significance, it means alpha is 0.05. It means that we are 95% confident that you are making a correct decision, a right decision. Or we can say that we may be wrong in our decision making with probability 0.05. This is fixed. You have fixed this. It should not be more than 0.05. Here, when we take the level of significance 5%, it means we may be wrong with probability 0.05. If you take alpha 1.01, that means 1% level of significance is there. What it means? It means you are 99% confident that you are taking a correct decision, and you may be wrong with probability 0.01. So this is very high. 99% acceptance probability is very high. So normally we take at 0.05. 5% level of significance is taken in this thing, testing procedures. Clear? So now again come to these are the basic terms. Clear ho gaya? If something is not clear, we can discuss afterwards. Clear? So just note down your questions and we will start discussion after the lecture. I'll just go for small techniques. आप मुझे बता दीजिएगा जब तक आपको चलना है, बट अभी मैं आपको सिर्फ सिंपल टी टेस्ट के टेक्निक्स बताती हूँ. द टेस्टिंग सिचुएशंस मैंने जैसे आपको पहले बताया कि इसमें टी टेस्ट के लिए वी आर इंटरेस्टेड इन द सिंगल सैंपल मीन. We may be interested in the testing of a single sample, single population mean mu, or we may be interested two sample means differ significantly or not, two different groups, two independent groups, and the third situation is two paired group, two dependent samples can also be there, paired sample technique, or we can test the variance also, variability of one population, variability of two populations. Here. So now what are the testing, the steps in testing procedures? How do you take the decision? आपको ये तो पता चल गया कि हम किस तरह से कौन-कौन सी situations में टेस्ट कर सकते हैं. We can test about the parameters, we can test about the distribution, and much many more. वो बाद में आपके आएंगे. What type of test can be there? We can talk. ये जितना भी हम टेस्टिंग की बात कर रहे हैं, they are known as parametric techniques because we are talking about the parameters. Normality. Parametric inference में what is the basic assumption, what is the main assumption? The population should be normal. अगर normality नहीं है, then you cannot use these tests. So then what to do? We have alternative tests, alternative sets of techniques available. They are called non-parametric techniques. So non-parametric techniques will use different assumptions. वहाँ normality तो रहेगी नहीं आपके पास. So once normality is not there, how to test that? So all these techniques are available. So abhi is lecture mein I will just go for few parametric techniques. So us parametric techniques se pehle let us see what are the basic steps in testing procedure. First of all, look at the data. मैंने क्या कहा था? Right statistical test. How to choose right statistical test? You just look at the data, look at the assumptions, then state the null hypothesis. So first of all, look at the data, because if the assumptions are not there, you cannot use the given test. For different assumptions, different tests will be there. After that, state the null hypothesis, state the alternative hypothesis. Then for these types of hypotheses, define the test statistics along with its distribution. And distribution will be under the null hypothesis, which is the exact one. Clear? Then the third step is compute the value of the test statistics from the given information, from the sample data. Now, these three things are there. Now, how to take the decision? Now, for decision making, you have to compare the calculated value of the test statistics with the tabulated value. This is the normal procedure. After the computation, you will go for the tables. The test statistics which you have used, the tables of that test statistics will be available. You compare your computed value with the tabulated value, and according to your hypothesis, you will take the decision. It depends upon whether you are going for one-sided hypothesis, whether you are going for two-sided hypothesis, you will take the decision. This is one technique. But these days, the things are very simple. You don't need to go for tables. You don't need to go even for these computations. There are so many statistical softwares available these days. You can simply put your data, the whole data sheet. It may be very large or very small, whatever. You can have thousands of variables. You just prepare one data sheet and go for different softwares and just select the test statistics which you want to use, you will be getting the results. किसी टाइम पे उस तरह का भी हम एक लेक्चर करेंगे. आई कैन अगेन डेमोन्स्ट्रेट ऑन दीज थिंग्स कि सॉफ्टवेयर कैसे इजी बना देते हैं हर चीज को. You are the mathematics people, you are statistics people, you don't find these things difficult. फार्मूला है, आप फार्मूले में वैल्यूज डालेंगे, कंप्यूटेशंस करेंगे, आपके लिए इजी है. बट दिस इज नॉट इजी फॉर अदर पीपल. तो वो क्या करेंगे, वो सॉफ्टवेयर यूज करते हैं एंड जस्ट विद वन क्लिक दे गेट द आंसर. और उसको डिसीजन कैसे लेना है, क्योंकि वो सॉफ्टवेयर में तो टेबल भी नहीं देखेंगे. दे विल जस्ट टेक द डिसीजन. दे टेक द डिसीजन ऑन द पी वैल्यू. एक ये कॉन्सेप्ट चलता है, ये थोड़ा सा टाइट है, इसमें शायद आपको इतना नहीं आएगा, क्लियर नहीं होगा, बट लेट मी एक्सप्लेन. यू गो फॉर पी वैल्यू. If your p value comes out to be smaller than your level of significance, if p value is less than 0.05, तो कहाँ लाई कर गया, वो क्रिटिकल रीजन्स में आ गया, एक्सट्रीम्स में आ गई आपकी वैल्यू, तो यू शुड रिजेक्ट द नल हाइपोथेसिस. एंड इफ योर p वैल्यू इज ग्रेटर देन 0.05, जो आपने लेवल ऑफ सिग्निफिकेंस लिया है, इट मींस इट इज फॉलिंग इन द एक्सेप्टेंस रीजन. So you accept the null hypothesis. So the things are very simple. Software कौन कौन से available है? I'll just tell you the names only. कभी आपको मौका लगता है तो आप देखिए, नेट से सर्च कीजिए. The most popular one, not most popular one these days is SPSS. SPSS. सभी सोशल साइंटिस्ट ये यूज करते हैं. वेरी सिंपल सॉफ्टवेयर. उसमें you can get all the solutions, all the test statistics, all the descriptives, all the graphs, all the diagrams, everything you can get from that. Okay? SPSS. Another one is ये तो बहुत costly है SPSS. The free one is PSPP. S को P से रिप्लेस कर दीजिए. You search on the Google, जाके आप सर्च कीजिए तो you can easily, ये आपको फ्री डाउनलोड मिल जाएगा, PSPP. So you can use any test statistics. You just use your data, put the data in the data sheet, select the test or select the descriptive measures, select the correlation coefficient, correlation coefficient, you will get the answer of all such questions. There is no need to use all these mathematics and all these computations. Clear? अभी पीछे एक और आया, स्टैट क्राफ्ट्स आया, that is also there. उसमें वो स्टैट क्राफ्ट्स में क्या कर रहे हैं, प्रोग्रामिंग भी साथ दे रहे हैं. They have used R programming. Okay, so many softwares are there. Even on Excel, you can go for these statistical techniques. Okay, so these are the steps in testing procedures. And one more thing is there, the concept of large sample and small sample is also there. So what is small sample in statistics? Normally, if your observations are less than 30, it is known as a small sample. And if the observations are greater than 30, it is considered to be large sample. Okay, so in large sample, the t-test will become z-test and so on. Yeah, so these are the steps, and just I'll demonstrate you 2-3 things. Sanji, Ramnivas, can I proceed further?
Yes, ma'am, you can.
Okay, I'll just Hanji, and बोलिए.
Yes, ma'am, you can proceed.
Okay, thank you. Clear? So now let us come to the t-test statistics. What is the t-test statistics? This is the basic statistics which is used in the statistical inference, and this is developed by Govt. And again, as I told you that if you are concerned about the testing the mean of the population, there will be 3 versions of this. When you are interested in the single sample mean of the 2 independent samples and 2 dependent samples. Yeah. So single sample, 2 dependent samples means 2 linked samples are there, paired samples. Okay. And if you look at the formula of these test statistics, they are very simple. Very simple formula is there. For example, let us come to the first problem. In the same data, can we say the average weight of the participants is 65 kg? We want the answer of this. First of all, we'll check the assumptions. We'll check whether the normality is there in the data or not. If it comes out to be the normal, we will go for t-test. If it is not normal, then you should go for non-parametric techniques. So many parallel non-parametric techniques are there. आज हम उसको नहीं कर पाएंगे. But if normality is missing, no problem. We have alternative sets of techniques available. Okay. So in this case, the first step is state the null hypothesis. How will you state the null hypothesis? Mu is equal to 65. Alternative is mu is greater than 65 or less than 65 or not equal to 65. Anyone. Now these three alternatives, this is called one-sided, upper tail. Mu is greater than 65. This is also one-sided. The second one is also one-sided. This third one, when we say mu is not equal to 65, this is two-sided alternative. So you can select any one depending upon your problem. Whatever you want to check. अगर आपकी statement ये कहती है the average weight of the participants is more than 65 kg, then you will go for the first one. Clear? So in this way you can select the alternative. Okay. So now, and the next step is, what is your level of significance? It is already predefined. It may be 0.05, it may be 0.01. Then we know that for this type of situation where normality is there, we are interested in testing the single mean, we should go for t-test statistics. And the sample size is also less than 30. Okay, so we should go for t-test. If sample size is more than 30, we'll go for z-test. Clear? So now the second situation, there are two groups now. Both the groups, they are independent, male and female. So what is the problem? We want to check that the average weight of the female participants is equal to the average weight of male participants. Mu f is equal to mu m. And any notation you can use. Mu f is equal to mu m. Now alternative can be any. If you assume, if you feel the weight of the male participant should be more than the weight of the female participants, then you should go for mu m is equal to mu f alternative. Or mu m is less than mu f, or mu m is not equal to mu f. Okay, so depending upon your problem, you can go for different alternatives. Clear? So then, what is the level of significance and the test statistics? And this test statistics is known as t-test for independent samples. मैं आपको test statistics का भी थोड़ा formula अभी बताऊंगी. Very simple formula for statistics students. It is not difficult one. Okay? And the third case is dependent samples. Same set of observation. Some treatment is given, and after that, again, the recordings of the weight is there. And we want to check whether the treatment is effective or not. Effective in the sense whether the treatment is given for the increase in the weight or decrease. Okay? Any diet plan is there, and we want to check the effect of that diet plan, whether it decreases the weight or not. Okay, so this type of sample, this type of problem is known as paired sample problem. Paired sample means dependent samples mean. Okay, so for one variable we have these three cases, and in all the three cases we go for t-test. Okay, and in the third one, how will you state the null hypothesis? Average of the difference is 0. There is no change of the treatment. There is no effect of the treatment. Okay, so mu d is equal to 0, and mu d may be greater than 0 or less than 0, whatever. Okay, this is a small example of one sample t-test. One sample testing one sample mean. So this is the statement about the mean cholesterol level of hypertensive men. Mean cholesterol in male general population from 20 to 74 years is considered to be 211 with the standard deviation of 46. We want to check this thing, whether the mean cholesterol level of this age group of males is 211 or not. We'll have a sample. A sample can be of 30 observations or even more observation, because um, we have another test available. Let us say the sample is less than 30 and we want to check whether the average cholesterol level in this age group is 211 or not. Okay. So the null hypothesis is average cholesterol level is 211, mu is equal to 211. And alternative is it is not 211. You can say more than 211 or less than 211, it depends. But let me tell you the test statistics. So variance will be unknown variance. Another assumption for the t-test is the population variance is unknown. First thing is it is normal, the distribution of the population is normal, and secondly the variance is unknown. We go for t-test, and third one is the sample size is less than 30. If it is greater than 30, it will approximately become normal distribution. Okay, the test statistics, look at the formula. This is x bar which you compute from the sample observations, minus mu naught, the value which is given under the null hypothesis. मैंने आपको बोला था ना टेस्ट स्टैटिस्टिक्स की वैल्यू वी कंप्यूट अंडर द नल हाइपोथेसिस, एग्जैक्ट वैल्यू होगी तभी होगा ना इसकी वैल्यू. Okay, and then this is the sample variance, sample standard deviation divided by under root of n. This follows t distribution with n minus 1 degrees of freedom. Okay, and after that, if you don't go for any software for the performance of this test, if you want to perform it manually, you will go for the critical values, the tabulated values. So any statistical book will be there or computer will be there, which will give you the critical value depending upon the value of n. The value of t will depend upon the total number of observations. Okay, and t distribution approximately becomes normal distribution for degrees of freedom greater than 30. So this is the formula of the t-test. Now let us say some data was there and we computed the mean out of that data. It came out to be 220. X bar aa gaya 220. And standard deviation that came out to be 38.6. Standard deviation to sabko nikalni aati hai na. All of you must be knowing about the formula of that standard deviation. Okay, so this came out to be 38.6 from that sample. Sample size kitna tha? 25. N is 25. Okay, so after putting all these values, the value of the test statistics came out to be 1.17. What is the next step? The next step is look at the value of level of significance, and the two-sided value in the table of the t-test will come out to be with how many degrees of freedom? N minus 1 degrees of freedom. N minus 1 degrees of freedom, the critical value comes out to be 2.064. ये टेबल से आई है वैल्यू. Okay, and your t value इसमें two-sided है, we take the absolute value of t. वैसे otherwise also it is positive. Even if it is negative, make it positive by taking the absolute value, and this value is smaller than the tabulated value. Tabulated value is 2.06, computed value is 1.17. So what do? You accept the null, you don't reject the null hypothesis. We fail to reject the null hypothesis. Okay? We fail to reject the null hypothesis because on the basis of these observations, so the difference is not statistically significant. The difference between the given value and the sample value is not very significant. So we accept the null hypothesis. The average cholesterol level is 211. Clear? So how you take the decision? This is the very small example. Okay, and then you can find out the confidence interval also. This is another technique to find out another technique to take the decision. If your value falls, if your value of the parameter, if your parameter falls in this region, then you accept the null hypothesis. If it does not fall in this, you reject the null hypothesis. अब देखिए इस केस में confidence interval क्या आ गया है? It comes out to be 204 and 235. 204.06 to 235.93, and your value was 211. It is definitely in these two values. So it means the hypothesis is accepted. The null hypothesis is accepted. Okay. So the critical, this confidence interval is also seen from the test statistics. आप इसको equate करेंगे tabulated value के साथ. This statistics will be equated, T will be equated to the tabulated value, and just solving it for x bar, x mu naught. Solving it for mu naught, it will give you the two limits for this unknown value. And if your value falls in these two limits, you accept the null hypothesis. Otherwise, you reject the null hypothesis. Clear? So this is one sample t-test. ये आपका paired का है. For paired sample t-test, the values just on the similar line. Because instead of x, now you will be using x minus y. Paired sample है ना? So xi minus yi is di. So find out d bar, and this is the formula for that. Variance of this di's and mean of this di will give you this formula, d bar s upon under root of n. Clear? And similarly you can take the decision, but यहाँ पे आपका थोड़ा degrees of freedom change हो जाएगा. So the n minus 1 same degrees of freedom will be there. Okay. Now this is for two independent samples. टू इंडिपेंडेंट सैंपल्स में हमने एग्जांपल लिया था मेल एंड फीमेल. यहाँ पे मैं कोई ऑब्जर्वेशंस के साथ एग्जांपल नहीं लूंगी, आपको सिंपल एक स्टैटिस्टिक्स बताऊंगी. अगर जेड टेस्ट यूज करना है तो उसमें सिग्मा इज नोन, द वेरिएंस ऑफ द पॉपुलेशन इज नोन, तो यू गो फॉर दिस टेस्ट स्टैटिस्टिक्स जेड. और अगर आपका वेरिएंस unknown hai, you have to find out the variance from the given sets of observation, then you will go for the second one. T is equal to x bar minus y bar upon s into 1 upon n1 plus 1 upon m under root. Okay, so ye formula, these are very simple formula, and you can easily get it from any book or from net. The only thing is you have to understand the procedure. कहाँ पे इसको यूज करना है, कैसे इसके assumptions को चेक करना है. Okay, so these things are important. तो ये देखिए आप, इसका आपका null hypothesis होगा mu1 is equal to mu2 और mu f is equal to mu m against the alternative that they are not same. Okay, तो ये आप टेस्ट स्टैटिस्टिक्स हैं, फॉर्मूले हैं इनके, और ये z टेस्ट भी ऑन द सिमिलर लाइंस. अब एक और बड़ा इंपॉर्टेंट टेस्ट बचता है, व्हाट आफ्टर टू मीन्स. You have used a t-test for one single sample mean. You have t-test for two sample means. But if there are more than two samples, then what? Then we go for ANOVA. ANOVA means analysis of variance. Analysis of variance. मैंने पहले शुरू में बोला था ना, what type of test you can use, and our answer is TF ANOVA. T हमने देख लिया. ANOVA में भी हम F test ही use करते हैं. उसके बाद F test can be used for the variability also. Okay, so but first of all, let us see ANOVA, analysis of variance. This is used for comparing the means of more than two populations. अब यहाँ पे आप देखिए, we have again same data. Our focus is on the weight of the participants. So what we can do, we can divide the weight of the participants according to their different regions. Maybe different languages, maybe different regions, maybe different age groups, and we can divide the sample, the whole data, into 4 subgroups, and we want to check whether the average weight of these 4 groups is same or not. Clear? So here we'll go for ANOVA. So this is called one-way ANOVA because we have just divided that sample one way, just according to their weights, they are divided. Okay. So one-way ANOVA is used to determine whether there is any statistically significant difference between the means of 2 or more, rather 3 or more independent groups. यहाँ पे भी independent samples की बात हो रही है. They are not dependent. Okay. So when you divide the whole group into 4 subgroups, they will be independent. Okay. So usually we have 3 groups. Now this is simple example. कहाँ पे यूज होगा, एक तो वो वेट वाला हो गया, that may not be very clear. So examination performance is checked on different groups of students. Examination performance differed based on test anxiety levels amongst students. तो इसमें क्या किया, we divided the students into 3 independent groups एंजाइटी लेवल के ऊपर स्टूडेंट्स को डिवाइड किया गया. The students who have low anxiety level, medium anxiety level, and high stress students. Okay, and their performance was tested. Test दिया गया उन students को, and finally, our aim was to check whether their performance was same or different. Clear? So these types of situations can be there. Weight wala to ek example diya tha, that was very simple. We want to check whether the average weight of these four groups is same or different. Here, the average performance of these three groups is same or different. Clear? So here the assumptions are variables should be measured at the interval or ratio scale. ये तो इन सारे टेस्ट में जो हमने किया है, t-test, all the three tests, and this is the fourth one, all the variables they should be either on interval or ratio scale. यहाँ पे हमारे पास nominal और ordinal scale का डाटा नहीं हो सकता, because we need continuous measurements, we need continuous observations. Okay, so then observations, independence of observations will be there, means there is no relationship between the observations in each group or between the groups. All the observations, they are independently, and there should be no significant outliers. The outliers की हमने पहले बात नहीं की है. So let me tell you, sometimes what happens when you go for the collection of the data, or when you pick a data from somewhere, you get some outliers which do not match with the observations. बहुत बड़े, even true भी होगा तो भी they will distort the picture. कई बार क्या होता है कि आप suppose you are collecting the data on the weights of the participants, and one or two students they come with very heavy weight. So if you consider these in the group, then you will see the average comes out to be much more than the exact one. So these types of situations are known as outliers. तो outliers नहीं होने चाहिए data में, otherwise your decision will not be correct. Clear? So first look at the outliers. Again, statistical software will help you to get rid of such outliers. Okay, but no significant outliers should be there in the data. Okay? So then again, the normality of the observation should be there. The subgroups, they should follow normal distribution, and the homogeneity of variance. Variability should also be same in all the groups. इसके लिए भी पहले टेस्ट किया जाएगा. Variability, how will you check the variability of the data? Clear? So there is a test for all that also. Lebanese test is there. अगर ये data में ये assumption नहीं चलती, तो we'll go for another ANOVA, Welch ANOVA, one-way analysis of variance, and Welch one-way analysis of variance. Okay, so these are the names of the different tests. And then another this application of this ANOVA is, suppose here you are testing 4 samples or 5 samples. You reject the null hypothesis, but out of the 4 or 5 or 6, any 2 of them can be same. So you can just group the samples into 2 pairs and go for the testing. So these types of tests, they are known as, these types of techniques, they are known as post hoc techniques. These types of techniques, they are post hoc tests. Clear? So this term is also very common. Comparing different means with the help of analysis of variance and going for post hoc tests. Okay, so this is one-way analysis of variance. This is the data. कोई भी data है. Let us say we have 4 types of treatments are there. 4 groups of observations are there, and we want to check whether all the 4 groups have equal means. All the treatments are equally effective. All the feeds are equally effective. Okay, so the null hypothesis will be either mu1 is equal to mu2 is equal to mu3 or mu4, or just treatments. The average treatment effect is same. Against the alternative that all feeds are not equally effective. ये पहला alternative है. Then second, we can just check T1 is equal to T2, or T2 is equal to T3, or T3 is equal to T4. Okay, so these pairs can be made. Okay, and this is the model. ये one-way analysis of variance model है. Mu is the overall mean effect. Ti is the mean effect of the ith treatment, and this is the error term, because every observation is a sum of all these things. अब देखिए हर ट्रीटमेंट का इफेक्ट इज कमिंग आउट टू बी डिफरेंट. व्हाई दिस इज, these are the observations you can say within the groups, these are between the groups, A और B between the groups हो गया. okay? तो these are the model. ये बेसिक मॉडल है जो एनालिसिस ऑफ वेरिएंस में लिया जाता है. वन वे एनालिसिस ऑफ वेरिएंस में the concept is about the error, because any observation is a sum of different effects. Overall effect due to that treatment, क्योंकि सेम ट्रीटमेंट आप देखिए कितने लोगों को दिया जाता है, बट द ऑब्जर्वेशंस आर डिफरेंट. पेट का ही एग्जांपल देख लीजिए, ऑल द पर्संस दे फॉलो द सेम ट्रीटमेंट बट different results are there. Okay, so treatment effect plus overall effect plus some error. Okay, so then this the simple formula are used, and getting the F test for analysis of variance, we go for F test. Okay, so these are the techniques, simple techniques है इसमें, इतना calculations में भी इतना मुश्किल नहीं होंगे, but if you go for any particular software, so then this just a 1 minute job, not minute, even second job. Yeah. Okay. So this is the again the procedure, and finally you get the sum of squares due to this. This will be ANOVA table. You have to prepare the ANOVA table after doing all these derivations, the total sum of squares, the error sum of squares, and the sum of squares due to treatments. And finally you will go for this value. F value आपकी क्या आ गई? F value is coming out to be 31.64. The F value after these computations, it comes out to be 31.64. And the tabulated value with these degrees of freedom, these degrees of freedom means 3 and 16 degrees of freedom, comes out to be 4.08. ये F tables में से you will be getting this value. Now what should be the decision? Because your computed value is higher than this tabulated value, what to do? You reject the null hypothesis. What it means? All the treatments are not equally effective. All the 4 treatments, they are not equally effective. Then we'll go for post hoc comparison. At present, it will be difficult to understand the formula for that. But in softwares, they are very easy to use. You can just go for, you can just click on different tests and perform the post hoc analysis. Okay. So this is the decision of this. From the given data, we conclude at 5% level of significance that the treatments, they differ significantly. Clear? So then we can go for test for variability also, because you know variability is equally important. First two-way ANOVA, two-way, this was one-way ANOVA. Two-way ANOVA is when the analysis is done on the 2 types of categories. We have 2 types of categories. Each observation is a result of 2 categories. Okay? Age, let us say age and treatment. Age of the person and treatment. Any type of example you can consider. Anxiety level की आप बात कर रहे हैं, anxiety level and age group. So this is two-sided. Okay, so and we have analysis for this two-way. This is called two-way analysis of variance. And again, analysis can be performed, and the F test will be used, and you will be getting the results. Okay. We wish to test the differences in the means of the 2 categories. Okay. So should we go for test for variability? बताइए. हाँ जी, Ram Nivas, Dr. Ram Nivas.
Yes, ma'am.
हाँ बोलिए.
What, ma'am?
हाँ.
Ma'am, you can keep it short, ma'am.
Okay. Test for variances. अभी तक हमने क्या किया? अभी तक हमने जितने भी टेस्ट किए हैं, they all were for means. So you can test all the parameters. Variability is also very important. Variability of the data is also very important. Why? Because if variability is more, then what is the use? If variability in particular data is very high, it should not be high. Okay? Now this is a simple example here. एक पैकेजिंग मशीन है and packing the mealy meal bags, but they received a complaint against the that weight of the bags. People complained that the weight is not 12.5 kg. Why? The consultant, he went there, he took a sample, and he found that the average weight is coming out to be 12.5. Where is the problem? People are complaining that the bags are not containing the exact weight, but the consultant, he found that the average weight is coming out to be 12.5 kg. What is the problem? The problem is that variability in the bags, in the meal, in the weight was very high. It will not be accepted in the market. Average is coming out to be the same, 12.5 kg, what is as per the specifications, but the variation is very high. So definitely the product will be rejected. Clear? अब देखिए ना, average of, let us say, if a person scores 100 marks and another scores 30 marks, 10 marks, what is the average? 55. 100 वाले को भी आप 55 कहेंगे, 0 वाले को भी आप 55 कहेंगे. And at the same time, if in class the two persons they score 55, then the average will be 55. But the variability is, no variability is there. But in the first case, variability is very high. Okay, so data to be more consistent, the variability should be controlled. Okay, so for that we have a test. This is in variability also. We can have single sample problem, we can have two sample problem, or even more than two samples. You can test simultaneously the variability in the single sample, variability in the two samples, and variability in more than two samples. Yeah. Now, this is the hypothesis when you are going for testing the single variance. The null hypothesis will be variability should be fixed. What is that? Sigma square is equal to sigma naught square. If it comes out to be greater than that value, how do you fix this value? The company specifies that this much variability is error, this much variability is acceptable. Okay, so that value can be fixed. जैसे अभी हमने एग्जांपल दिया था ना उसमें सॉफ्ट ड्रिंक बॉटल्स का, the company made the specification that the variability is 10 ml. The sigma square was 10. If it is more than 10, then we can say the variability is more and it should not be accepted. Okay, so the null hypothesis is that fixed value and alternative is greater than that. Okay, and for this problem we'll have the chi-square test. This is for the two sample, but for the single sample, two sample problem, suppose you want to compare the efficiency of the two machines. There are two packaging machines, A and making machine B. Which one will be better? Which machine will be better? With the machine which is giving the less variability. That will be definitely better. Okay, so in this case we check the variability of the two machines. Okay, and this can be done by using F-test. See how to do this thing. In this case, the null hypothesis will be two variances are same. Sigma A square is equal to sigma B square against the alternative that sigma A square is not equal to sigma B square. Okay, so variability के लिए कितना होगा? Because for every test you make the assumption. For example, in test for two independent samples, you made the assumption that the variability in the two tests is same. In ANOVA also you made the assumption that the variability is same. Okay, so how to check that? For that we need these tests. The single sample variability can be tested by using chi-square test, and the variability in the two samples that can be tested by using F-test. Yeah. So there are so many applications because variability should be controlled. प्राइस स्टेबिलिटी के लिए भी चाहिए, हमने स्टॉक मार्केट में भी, फॉर द करेंसी ऑल्सो, ऑल दीज थिंग्स द वेरिएशन शुड बी कंट्रोल्ड. Now this is the test hypothesis for the single sample variability chi-square test. इसमें आपका hypothesis होगा sigma square is equal to sigma naught square. Alternative is sigma square is greater than sigma naught square, or not equal to sigma naught square भी कह सकते हैं आप. Okay? But this is the exact one. जहाँ पे variability ज़्यादा आएगी वहाँ पे ही आप reject करेंगे ना. Okay? The product will be rejected if the variability is high, variability is more. Okay? So one-sided alternative will be sigma square is greater than sigma naught square. And the test statistics will be based on this n minus 1 s square upon sigma naught square. This is the chi-square test, chi-square statistics. Yeah? So this is, and of course the tables are available for chi-square distribution based on the degrees of freedom. You get the value from the tables or get the p-value and compare the test statistics. Same example अभी हम लेते हैं, yeah, this one, the milli-meal bags में. Okay? So 12, we have taken a sample of size 12, and out of that the variation came out to be 0.0025. And the null hypothesis was sigma naught square is 0.0016. इतना वेरिएशन हमारे पास सैंपल में आया, but that company fixed the variation. This variation is fixed. The machine was designed to operate with the precision of this 0.0016 variation. इतना वेरिएशन मैक्सिमम हो सकता है उस पैकिंग में. But what happens when we collected the data and checked the variation, that came out to be 0.0025. Now our problem is, does this data indicate a significant increase in the variation? क्या उस प्रोडक्ट में इतना इंक्रीज हो गया था? Okay? So again the test statistics जो अभी हमने स्टेट किया used to be this, after using the test statistics the value came out to be 17.2. And यहाँ पे हमने p value निकाली है, p value is coming out to be 0.143. So what was the technique by using p value? If your p value is less than 0.05, then you reject the null hypothesis. Otherwise, you don't reject the null hypothesis. Okay, so value is greater than 0.05. It means there is no significant increase in the variance. The product should not be rejected on the basis of this variability, this much variability. If there is a significant increase, अगर आप hypothesis को reject कर देते, so then we could have said that the hypothesis should be rejected, the product should be rejected because they are not producing the things as per the specifications. Okay, so this is one sample variability. Similarly, you can go for two sample variability. We can compare. Suppose we want to select one machine. Which one will be selected? Which will give you the less variability. Okay, so for checking this, we need to use F test. Okay, so this is the statement about the test statistics, SA square upon SB square, and ये आपका F distribution का curve है, because you must know the curves of the distributions, what type of shape this distribution can take, and जहाँ पे shaded region दिया है, that is the region of the rejection. 5% level पे ये region क्या आएगा? So this is the rejection region, and on the basis of this you can take the decision. ये छोटा सा एक example है. Sample size can also be different because they are independent samples. First sample it gave you the value 0.0035, and the second sample gave you the value 0.0016. Okay, so does this data provide evidence that the working precision of the two machines are significantly different? So sigma A square is equal to sigma B square. F test is used. The value came out to be 2.99. Similarly, you can find out the tabulated value or p value and go for the decision, go for the conclusion. Okay, so this is all. I have not touched the non-parametric techniques. मुझे लगता है कुछ लोग चले भी गए हैं छोड़ के. So now we can come to the discussion part. If anybody wants to share something and anyone wants to ask question, you can ask. Hanji. Anyone?
Is there any question from the audience? Please ask or raise your hand.
And you just unmute yourself and ask the question. Rimi Sharma has raised the hand.
Ma'am, there is a question from one participant. What is the difference between p-value and test level of significance?
Okay. मैंने आपको अभी I told you earlier also p-value or level of significance, p-value is the exact level of significance जो आएगा आपका test statistics से. Because these days software में p-value easily they can compute and they give us the p-value. And it is suppose in one particular case अभी हमने कौन सा टेस्ट किया था chi-square वाला जो टेस्ट किया था उसमें exact निकाला था. Let me come to this thing. I'll show you the slide. Chi-square this one. Now here look at the value of chi-square. This value is 17.2. ये आपकी calculated value आई है. If you compute this value, exact value, chi-square is greater than 17.2. ये भी आपको टेबल से मिल जाती है. कई बार आप डिस्ट्रीब्यूशन से भी कंप्यूट कर सकते हैं ये वैल्यू. दिस इज द पी वैल्यू. ये आपकी पी वैल्यू आती है. But if you look at the tables, for what value of this comes out to be 1.143, जो P आपका level of significance against value आएगी, that will be your alpha. Alpha पे आप tables देखेंगे, पर P value को आप इससे compute करते हैं. You understand? P value alpha से ही related है. It should not be more than, if it is more than alpha, you accept the null hypothesis. अभी यहाँ पे इतना easy नहीं है because I am not familiar with this Google Meet. मैं WebEx use करती हूँ, उसमें तो मैं पेन से draw करके दे देती हूँ. This is the limitation of the Google Meet because I cannot draw the picture. Okay?
Okay. There is another question from Rimi Sharma. Rimi Sharma, please ask your question.
Yes, please.
Good afternoon, ma'am.
Good afternoon.
मैम एग्जैक्ट डेफिनेशन क्या होगी लार्ज सैंपल टेस्ट की? हमें ये बोला जाता है कि जब 30 से ग्रेटर होता है तो लार्ज सैंपल होता है, पर कितना लार्ज? मतलब 31 भी लार्ज में काउंट होगा, 32 भी लार्ज में काउंट होगा?
Yes, it's very good question because normally students they ask this question. देखिए आजकल जहाँ पे ये आजकल सॉफ्टवेयर की बात आती है वहाँ पे तो इवन लार्ज सैंपल वाले को भी टी टेस्ट ही बोला जाता है. Because you see that when value crosses 30, आपकी टी वैल्यू जो है अगर 30 क्रॉस कर जाती है तो उसके जो टेबुलेटेड वैल्यू बनती है वो नॉर्मल के इक्विवेलेंट आ जाती है. सेम वैल्यू विल बी देयर. इवन 31 पे भी वैल्यू आपकी नॉर्मल की इक्विवेलेंट होती है. दैट्स व्हाई दे टेक 30. आप जाके टेबल चेक करना. आप जब टेबल चेक करेंगे ना 30 तक वैल्यूज दी हुई हैं, उसके बाद जो नेक्स्ट वैल्यू आएगी वो नॉर्मल टेबल के साथ सिमिलर आ जाएगी. क्लियर?
मैम नॉन पैरामीट्रिक के केस में?
नॉन पैरामीट्रिक के केस में तो हम कम स्मॉल सैंपल के लिए ही लेते हैं. In case of non-parametric test, small sample we take up to 30.
Is there any
non-parametric में there is another thing. Let me tell you because मैंने अब मुझे पता होता अभी मैं अगर non-parametric में interested हो तो I can continue with that also.
No, ma'am, please.
आप कभी फिर कभी कर लेना, कोई बात नहीं.
Is there any other question from the audience?
नहीं, नॉन पैरामीट्रिक का मैं आंसर दे देती हूँ इनको. नॉन पैरामीट्रिक में ऐसा होता है कि if your sample size is small, then you go for exact test. And in case of large samples, most of the non-parametric tests they become normal, asymptotically normal. Clear? तो उसमें तो प्रॉब्लम वैसे ही सॉल्व हो जाती है. दे गो फॉर नॉर्मल टेबल्स. और नॉन पैरामेट्रिक में कुछ थोड़ी लिमिटेशन भी है. कई टेस्ट स्टैटिस्टिक्स की जो टेबल्स हैं दे आर नॉट अवेलेबल. Tables are not available and you approximate the value with the help of the normal tables. Clear? बाकी नॉन पैरामेट्रिक एक हमें जो एडवांटेज है वो ये है कि वो बहुत छोटे सैंपल के लिए भी हम यूज कर सकते हैं, whereas पैरामेट्रिक टेस्ट वी कैन नॉट. अगर आपको सपोज 5 ऑब्जर्वेशंस हैं, 6 ऑब्जर्वेशंस हैं, so then we should prefer non parametric test.
Yes, Lavlit, you can ask your question.
Good evening, ma'am.
Good evening.
Ma'am, if we have to calculate the sample size, we have to have two things: standard deviation and margin of error.
नहीं, सैंपल में देखिए मैं जो बात कर रही हूँ आपको सैंपल साइज की कंप्यूटेशन के लिए हमारे पास ये तो जो फॉर्मूले हैं उससे पहले हम
Ma'am, actually, I want to calculate the sample size as I am working as a statistician in a hospital. So, ma'am, for a research purpose, I have to calculate the sample size, and for that, I have required the standard deviation and margin of error from pure study, from historical study.
नहीं, आप ऐसा है ना, उसमें मैंने आपको भी एक फॉर्मूला बताया था, दैट इज द फेमिलियर फॉर्मूला जो Z स्कोर है. Z स्कोर मींस जो आपका उसमें टेस्ट Z स्कोर का आप लेंगे ना, दैट डज नॉट डिपेंड वैल्यू ऑफ n 1.96 होता है.
Actually, Z score I have taken 5% level of significance. At 95% level of significance, that is equal to 1.96.
मैं वही कह रही हूँ ना कि Z स्कोर आपका 1.96 हो गया, 5% लेवल पे 1.96 आएगा ना टू साइडेड में. क्लियर? तो उसमें Z स्कोर स्क्वायर into variance divided by the margin of error. The formula is like that only. वो फॉर्मूला बड़ा कॉमन है, यू कैन जस्ट सर्च फ्रॉम एनीवेयर. मैंने इसमें मैं पूरे लिख पाई, तो दैट विल गिव यू द सैंपल साइज. वही फॉर्मूला आजकल ज्यादा यूज करते हैं हम सैंपल साइज के लिए. Clear?
Is there any another question from the audience?
हाँ जी, लवप्रीत.
Hello.
Yes, yes.
You are audible.
Ask your question.
Okay, ma'am. Thank you for such a nice and wonderful session, ma'am.
Rather, I am sorry because it got delayed. Actually, I was using Mac. Apple का जो लैपटॉप है, it was creating a problem, and Google Meet मैं बहुत कम ही यूज करती हूँ because मैं जो ऑनलाइन सेशंस लेती हूँ WebEx पे लेती हूँ या मैं Zoom पे लेती हूँ. So that's why there was an initial problem. So I'm really sorry for that.
It's okay, ma'am, but last everything is fine.
Ma'am, actually I have.
Yes.
Ma'am, मैंने सैंपल साइज कैलकुलेट करना है, तो उसके लिए मेरे को स्टैंडर्ड डेविएशन और मार्जिन ऑफ एरर चाहिए जो हमारी पुरानी वाली स्टडी से मिलेगा. अगर मैम पुरानी वाली स्टडी में हमें स्टैंडर्ड डेविएशन नहीं मिलता है, तो फिर हम कैसे लेकर चलें कि हमारा सैंपल साइज कितना होना चाहिए?
मुझे ये बताओ कि स्टैंडर्ड डेविएशन क्यों नहीं मिलता है? क्योंकि स्टैंडर्ड डेविएशन तो आपके पास होगा ही जब इफ यू हैव द डाटा, देन स्टैंडर्ड सैंपल शुड बी दैट स्टैंडर्ड डेविएशन.
I go through the papers, but in those papers they're not given the standard deviation and margin of error. तो मैम एक अभी तो मैम हमने ऐसे ही देख लिया कि जितने पेशेंट हमारे आएंगे हम उसी के बेसिस पे हमने मिनिमम सैंपल साइज ले लिया उसी के बेसिस पे. पर मैम पुराने पेपर्स में पुरानी स्टडी में कहीं पे भी मेरे को स्टैंडर्ड डेविएशन ऑफ एंड मार्जिन ऑफ एरर नहीं मिला.
नहीं, आप देखिए मैं आपको एक बताती हूँ व्हाट इज मार्जिन ऑफ एरर. मार्जिन ऑफ एरर तो आपका कॉन्फिडेंस इंटरवल से आएगा ना. मार्जिन ऑफ एरर विल कम फ्रॉम द कॉन्फिडेंस इंटरवल. मैंने अभी एक आपको बताया दैट इज द डिफरेंस बिटवीन द अपर एंड लोअर वन. ये देखिए फॉर्मूला आपको शीट पे स्क्रीन पे नजर आ रहा है. जस्ट लुक एट द फॉर्मूला, है ना. नेसेसरी सैंपल साइज इज Z स्कोर स्क्वायर into standard deviation into 1 minus standard deviation.
Yes, ma'am.
Divided by margin of error square.
Yes, ma'am.
है ना. तो मार्जिन ऑफ एरर जो है आपका, जो इंटरवल आता है ना, अपर एंड लोअर वन, दैट इज द, देखो मार्जिन ऑफ एरर इज कॉन्फिडेंस इंटरवल,
Yes, ma'am.
है ना।
Or we can say the
मेडिकल
difference.
फील्ड में इतना
Or
हम इसका स्टैंडर्ड डेविएशन का इतना सैंपल साइज का हम इतना बॉदर नहीं करते हैं, वी टेक वेरी स्मॉल सैंपल साइजेस। मेडिकल में तो बिकॉज लाइफ एक्सपेरिमेंट्स आर इन्वॉल्व, तो वी डोंट टेक लार्ज सैंपल। उसमें कोई ऐसे हार्ड एंड फास्ट नहीं है कि आपको कितना सैंपल साइज लेना है। आपका जितने पेशेंट्स आ रहे हैं, यू परफॉर्म योर एक्सपेरिमेंट एंड सी द रिजल्ट्स।
okay, ma'am.
बल्कि आपके मेडिकल स्टडीज में तो वी यूज द कॉन्सेप्ट ऑफ सेंसरिंग आल्सो, वी टेक द डाटा अप टू फिक्स टाइम, इसके आगे हमने नहीं जाना बिकॉज ऑफ द लिमिटेशन। सो उसमें तो सैंपल साइज कितने ज्यादा वो भी नहीं होती। और पिछली पुरानी स्टडीज में यू जस्ट लुक एट द वेरिएबिलिटी इन द डाटा, मार्जिन ऑफ एरर विल बी देयर फ्रॉम द कॉन्फिडेंस लेवल इंटरवल से जो आएगा आपका, दैट विल बी देयर। तो इसका ना एग्जैक्ट देख लेना फॉर्मूला जो प्रॉपर होगा, बिकॉज मैं आई वाज नॉट एबल टू राइट इट प्रॉपरली, बिकॉज इसमें अभी हमने हमारा कोई सैंपल साइज डिस्कस करने का इतना नहीं था।
Okay.
एनीवन
Thank you,
एल्स?
ma'am.
मैम मैम इन रिग्रेशन एनालिसिस हम नॉर्मल इक्वेशंस को नॉर्मल क्यों कहते हैं मैम? और जो प्रोबेबिलिटी का सम भी वन होता है उसको भी हम नॉर्मलाइजिंग कंडीशन कहते हैं।
अभी मैंने वैसे रिग्रेशन तो नहीं करवाया आपको।
ओके मैम।
अभी हमारा रिग्रेशन वाज नॉट द टॉपिक फॉर डे, बिकॉज उसमें अलग फिर कंडीशंस चलती हैं। उसमें नॉर्मल इक्वेशंस अलग बनेगी, उसमें नॉर्मलाइजिंग इक्वेशंस अलग बनेगी, दैट इज अ डिफरेंट थ्योरी, वो लीस्ट स्क्वायर थ्योरी से चलता है सारा। In regression analysis, we use least square theory and we try to minimize the error sum of squares.
मैम व्हाई मैम उनको नॉर्मल ही क्यों कहा जाता है? द टर्म नॉर्मल मतलब किस लिए यूज की जा रही है? जब सम
हर टेक्निक में एक तो हम नॉर्मल डिस्ट्रीब्यूशन यूज करते हैं।
ओके मैम।
मतलब जो हमारी assumptions होती है, अब रिग्रेशन एनालिसिस में भी we take a linear model, x y is equal to x plus अल्फा प्लस एक्स बीटा प्लस एप्सिलॉन, ये आपका मॉडल होता है रिग्रेशन एनालिसिस में। एंड वी मेक द अजम्पशन जो एरर्स हैं दे डिस्ट्रीब्यूट नॉर्मली विद मीन 0 एंड वेरिएंस सिग्मा स्क्वायर। तो y की भी जो डिस्ट्रीब्यूशन है वो नॉर्मल हो गई। तो मैंने आपको आगे बताया कि जितने भी हम ये सारे टेक्निक्स की बात कर रहे हैं, दे ऑल आर पैरामेट्रिक टेक्निक्स। और पैरामेट्रिक टेक्निक्स क्या होते हैं? वेयर वी अज्यूम द नॉर्मेलिटी ऑफ द पॉपुलेशन। क्लियर? तो उसमें तभी कहते हैं ना कि ये फिर लीस्ट स्क्वायर थ्योरी को यूज करके नॉर्मल इक्वेशंस निकाली जाती हैं उसमें रिग्रेशन एनालिसिस में, बिकॉज दे आर बेस्ड ऑन दिस अजम्पशन ना। रिग्रेशन में भी, इवन कोवेरिएंस में भी, जब आप बायवेरिएट सैंपल ले रहे हो एंड यू अज्यूम दैट दिस इज फॉलोइंग द बायवेरिएट नॉर्मल डिस्ट्रीब्यूशन। क्लियर?
यस मैम, थैंक यू मैम।
ओके ओके, यू आर वेलकम।
Thank you, ma'am. All the things you shared through this webinar will go a long way in making us understanding statistical better, because you already explained various various testing procedure for testing significance of mean as well as variability. We are truly grateful to you for taking out time for your busy schedule and for enlightening us with such a well-researched and scholarly information. Thank you, ma'am. Thanks a lot once again.
Thank you very much. Thank you very much. But ऐसा है कि in future also if you face any type of these problems, so you can just no, जो बच्चे भी करना चाहते हैं वो they can ask me anytime.
Okay. I would also like to thank our principal, Dr. Balraj Thapar, for presiding over the session and encourage us to organize the webinar. Another big thanks is due to the management of the college for their support and motivation. Last but not the least, no webinar is possible without the utmost support of the faculty member of the college and the students. So once again, I sincerely thank you all for being there for the webinar. Thank you. The participants may now exit the meeting. Thank you once again.
Thank you very much. Thank you.
Thank you.
है।